Okay, these are our solutions for the work and power worksheet. First question, what is work? Okay, work is the result of a force moving an object. What that means, really, work is the force times the distance an object moves. But that force has to be causing the object to move. When we look at the units for work, work is force times distance. The units for that are newtons times meters. Well, 1 newton times 1 meter is 1 joule. So our unit for work is the joule. The unit for work is the joule. All right, so when is work positive? Work is positive if the force is in the same direction as the displacement. The idea here is that we do positive work when our force actually causes something to move. Work is negative if the force is opposite the direction of motion. If an object is moving and there's a force against that direction of motion, that force is acting to, trying to cause the object to slow down. All right, and then zero work is done by a force if the force is perpendicular to the motion. All right, if the force is perpendicular to the motion, that force is there. It may be supporting the object, but it's not causing the object to move, and it's not causing the object to slow down. That's the perpendicular part of it. So if you apply 100 newtons of force to a large box and push it a distance of 5 meters, how much work have you done? So in this case, here's your box. You're pushing with 100 newtons, and you move the box 5 meters. So here we have positive work because the force is with the motion. So our work done here is the force times the distance. So that's 100 newtons of force times 5 meters. That gives us 500 newton meters or 500 joules. That work is positive 500 joules. So if you apply 100 newton force to a box and that box doesn't move, so here's our box, you push with 100 newtons, but the displacement is 0 because the box doesn't move. No movement in this case means no work. So we have 0 work is done, 0 work done here. Because there is no movement, we're not going to have any work. You're exerting a force, you're exerting effort physically, but the work done on the box is 0. In order for an object to have work done on it, it has to move. So we'll write that down. In order for work to be done on an object, that object must move. No movement, no work for that object. Number 5, a large box is moving to the right at a constant velocity. You apply a constant force of 100 newtons, which brings the box to a stop. How much work have you done on the box? So we have the box that's already moving. So it has a velocity this way, and it's going to move 3 meters. That's its displacement. But you are pushing with your force of 100 newtons this way. So looking at that, your force and the displacement are in opposite directions. So we have negative work. Here we have the force not causing the motion, but opposing the motion. And so my work is going to be negative 100 newtons times 3 meters. Well, that work is going to be negative 300 joules. That's the work required to stop the box in that case. So if we have a large box moving at a constant velocity and no force is acting on it and the velocity doesn't change, even though the block moves, no work is done. We must have a force. We must have a net force to do work. Right? Work is force times distance. So even though we go 12 meters, there's no force, so there's no work done. All right. Number 7, you lift a 50-meter box to a height of 5 meters. So here's our box. Its weight is 50 newtons. Its mass is 5 kilograms. Its weight is 50 newtons. If you're going to lift it up, your force, your force is also 50 newtons. And then we're going to lift the box up 5 meters. So when you do work, you do positive work because the force is with the displacement, in this case delta y. So the work that you do is going to be positive 50 newtons times 5 meters. So the work that you do is 250 joules, positive. That's how much work you do. For gravity, looking at gravity, that's going to be negative work. Gravity does negative work. mg is opposite r delta y. So the work done by gravity in this situation is negative 50 newtons times 5 meters because they're in opposite directions. So the work done by gravity is negative 250 joules. You are helping the object to move. Gravity is trying to work against you. That's why it's going to be negative work. All right, a crane at the docks is capable of doing 1,200 joules worth of work. How high can it lift a load that has a mass of 40 kilograms? So if we look at our box, the mass of 40 kilograms, I know right away that the weight is 400 newtons because it's mass times gravity. And then the force of the crane, if it's going to lift it, has to be 400 newtons. And then we're going to lift it up some unknown distance that we don't know. So I know that the work the crane can do is going to be force times that delta y, that distance up. Well, the work of the crane is 1,200 joules. That's the maximum work it can do. It needs to apply 400 newtons of force. And then we got to find the distance that it's going to be able to lift our object. So here we'll divide both sides by 400. That goes away. And my delta y comes out to be 3 meters. Next one, how large of a force would be needed to perform 60 joules of work over a distance of 0.4 meters? All right, with this, again, we're just doing work is equal to force times distance. So we have 60 joules of work is equal to a force we don't know times a distance of 4 meters. divide both sides by 4, and 15 newtons comes out to be our force. Okay. Power. Power is the rate that work is done. Or more specifically, how quickly work is done. How quickly work is done. So when we're looking at power, power is work over time. So our units for that are going to be work, which is joules per second. But 1 joule per second is 1 watt. We use a capital W, and it's a watt. 1 watt of power. So how much power is exerted if you lift a 200 kilogram barbell to a height of 1.8 meters in 0.8 seconds? So let's draw our little picture. We have a 200 kilogram barbell. Its weight, mg, is 2,000 newtons, and then you have to lift it, so your lifting force is 2,000 newtons. So, if I want power, I need work over time. Work is force times distance over time. My lifting force is 2,000 newtons, so 2,000 newtons, times the distance of 1.2 meters in 0.8 seconds. So that power, when you multiply everything out, comes out to be 3,000 watts. Next one. 2 football players are running up the bleachers at a football field. Larry has a mass of 120 kilograms. Hector has a mass of 100. The bleachers have a height of 12 meters. Work done by each football player. So, Larry, if he is lifting himself up, what do you say? Larry has a mass of 120 kilograms. And so Larry's weight is 1,200 newtons, and Larry's lift force has to be also 1,200 newtons. So the work that Larry does is going to be that lifting force times how high he goes, delta Y. So 1,200 newtons times 12 meters. That's going to be 14,400 joules. That's going to be Larry's work. Then if we look over at Hector, Hector has a mass of 100 kilograms, so his weight is 1,000 newtons, and Hector's lifting force is also 1,000 newtons. That's how much it's going to take to lift up. So if we're looking at Hector here, his work is going to be his lift force, 1,000 newtons, times 12 meters. That's how high he's going. So his work is 12,000 newtons. I'm sorry, 12,000 joules. All right, if Larry... All right, so Larry's power is going to be Larry's work divided by his time. So that's going to be 14,400 joules for Larry divided by 20 seconds. So Larry's power is 14,400 divided by 20, or 720 watts. That's Larry's power. Hector's power is going to be Hector's work divided by Hector's time. So 12,000 joules of work for Hector divided by a time of 15 seconds. So Hector's power comes out to be 800 watts. So even though Hector is doing less work Then Larry, he's doing it faster, so he has more power. We put a burrito in a 1400 watt microwave, and we want to know how long it takes to absorb that much heat. Heat energy is what's going to stand in for work here. So we know that power is equal to work over time, or in this case, power is going to be energy over time. So the time, to solve for time, we multiply both sides by time. So time is now on the top. We want to isolate it, so we'll divide both sides by p. So that time is energy over power. So that time is 1.26 times 10 to the 4th joules of heat divided by the power of 1400 watts. So putting that into your calculator, that time comes out to be 9 seconds. And last one, how much work is done by a centripetal force? 0. Centripetal force is always perpendicular to the motion. So if we look at a circle, and if we're moving in a circle, that wasn't a great circle. So if we look at a circle, the velocity or our motion is always parallel to the circumference of the circle. And we said that the centripetal force always points in. Those two are right angles to each other. If a force is perpendicular to the motion, no work is done.